Mathematicians, math lovers, let's go through number 2, and let's quickly just I don't know, hit it hard. So here it says graph the curves over the given intervals. Okay, no problem. Graph the curves. So that means, well, number one, we should know, let's just do the concepts first. We should be able to graph the curves. Which ones? We can see here there is a sine x, then there's a sec. So let's just see if we are good at that. I mean, we should be able to do that. Let's do the graph of y of sine x. We say y equal to sine x. Remember, a graph should have y and x, okay, because there's a y-axis and the x-axis. So here is the graph, y equal to sine x. We want to put the graph of this. Sometimes you can see it being written as f of x equal to sine x. We know that f of x is just another way of saying y, okay. Now we should be able to put the graph of sine x of y equal to sine x. How do we do that? Well, you can use your calculator. This is so easy because you need to have positions that are of importance to you, and these positions are 0 degrees, then 90 degrees, then 180. So I should maybe move 3 like this. 90 degrees, then 180 degrees. Okay, we use 90s. Then we can say 270 degrees. Then revolution ends at 360 degrees. Now, and here you can see that they are saying from what? From negative 3 pi over 2 all the way to 2 pi. I mean, we can go back again to these like this. You should be able to do it for pi's, because here this would be negative 90. Let me make them smaller so that you can see everything. Okay, I don't want this to ever confuse you. I want us to master it once and for all. This is nothing. Curves are fine. Curves are not even a problem. We don't have a problem with these. So let's put it. Now, what you should know about the graph of sine x and of cos x is that the graphs begin at 1 and end they range from 0 to 1, okay, in the positive and in the negative. So they end at 1, they never pass 1, okay. In the negative it will be a -1, but we know it's just a 1, but in the other direction, okay. So this graph never passes the value of 1. Now we can put our 90s here to say, okay, here maybe let me put this as my 90, then this my 180, okay, then here this is my 270, okay, and of course finally somewhere here as my 360 degrees, okay. And if I'm putting as pi, you should be able to do it in pi as well. This becomes 90, this is 180, this is 270, then right now here is we have 360, then of course it keeps going. Now you must be able to do it as well in terms of pi, okay. This is going to be 180 is pi, okay, so that means this is pi over 2, and then this is 3 pi over 2, 3 pi over 2, then this is 2 pi, okay, which is 4 pi over 2, okay. This is like 1 pi over 2, then this is like 2 pi over 2, like to say 2 pi over 2, it just remains as a pi, then 3 pi over 2, then 4 pi over 2 is 2 pi, okay. So that's what happens. But these are the negative ones, so you should say negative, 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 negative. Again, what is 90? It is pi over 2, but it's not positive. What's 180? It's pi itself. Then this one, 3 pi over 2. Then this one, 2 pi. So here we have our things. You can put it in either rad or whatever. Now we want for y equal to sine x. So you know what you just do? If you want to do it in rad, then you make sure your calculator is in rad. Then you can be punching the things, okay? If you want to do it in degrees, you make sure your calculator says DEG at the top. It should say DEG, okay? Then you should be able to change it to from whatever. You change using the button which says DRG, okay? And you'll be looking at the top of your screen. If it's saying DEG, it's in degrees. If it says rad, it's now in radians. So here they want us to plot in radians, so that means we're going to be using radians. So these guys are not there, okay? So we can remove these guys, this guys, but it's like the same. So you can go to your calculator and put pi over 2, or if you want to, you could have said that this is 90 degrees. You can punch as a 90. So what you'll be doing is you'll be saying sine, then you say open bracket pi over 2, okay. The pi button is there. If you want to put the pi button, it is there in your sharp calculators, right next to the DRG button. Make sure your calculator is in rad. So I'm doing that to mine here. Then I'm going to say what is sine, open bracket, pi over 2, like you press the button which says AB over C, it's the over, okay. Pi over 2 close is equal to, I get a 1. So that means here at 90 or pi over 2, we are at 1. You can start with sine of 0. There is a 0 here, okay, and you get what? You get a 0. Now if you say sine of pi itself, just punch sine pi, you must get a 0 again. So you come and put it here. So you'll be say sine pi. So you use a calculator to put these things, and you know that it's just going to be saying 0, 1, 0. Then the next position will be a minus 1. So I can know that this will be a minus 1. Then it is going to be back to 0. Just like here, it's at 0. So that means we can try it since it is coming from a 1. Right now it's at a 0. So it's going to go to a minus 1 on the next position. Then from minus 1, it goes back to 0. Then from there, it goes to 1. Then it goes back to 0. So if you then plot the graph, here is what the graph would be like. It will be now curving. You curve down. Then you go down like this. You curve. You go back up. You curve, right? Then you go back up. It goes like this. Then you curve. Then you go back down. Then you go like this. Then you curve. Then you go back up like this. So this is going to be the graph of, you can put here to say this is going to be your graph of y equal to sine x. Okay, remember, I'm not just answering the question. I'm not really answering the question, because if you're answering the question, then they don't want this other part. They want you to start at 3 pi over 2 and end at 2 pi, negative 3 pi over 2 and end at 3. So this is where you would end, right? But yeah, of course, which is like to answer the question as well. But I want you to see all the different types. So this is the graph of y equal to sine x. And now how do we then draw the graph of the guy which is 1 over sine? Let's put it. So we've just been seeing, oh my goodness, I don't know how I did that. So sorry for that. So now I want to see, how do I then do, remember we said we have a guy called cosec, and cosec is equal to 1 over sine x. So now we want to do the graph of cosec x, the graph of cosec x. And we know that cosec x is the same as saying 1 over sine x. So how do we do that? Using the graph of sine x. We can use the graph of sine x to do that. So let's say this is 90, which is in the pi over 2. Then this is pi. Then this is 3 pi over 2. Then this will be 2 pi. Okay, you can see here they said, look at it. Well, I can show you what I've been saying. We say that, you can see here it says do from negative 3 pi over 2 to 2 pi. That is why we are doing what we're doing. Okay, so if we want to be putting, you can say, okay, so here this is going to be what? From here it's negative of pi over 2. Then here it's negative of pi. Then right here is negative of 3 pi over 2. Then right here it's negative of 2 pi. Right? So what is it going to be now if we have something like this? Then, well, now you should be able to use this graph. So how do I then use this graph to plot the graph of cosec? Because I can see they also want me to plot the graph of sec, and I want to show you where it comes from. So how do I plot the graph of cosec? Well, you just go to everywhere where your graph of sine was reaching a value of 0. Okay, if you want to plot the graph of cosec, you ask yourself, cosec is 1 over what? It's 1 over sine. So you should use the graph of sine x to then do for cosec. Wherever it was 0 like this, then you know that you are going to have an asymptote. So we can say, okay, there is an asymptote here at this line at the y-axis. Then there is, where else did it become 0? At pi. So we can come to pi and we put an asymptote dashed line. We know that there's going to be an asymptote at pi, or at, sorry, 180 is 2 pi, not pi rather. No, it's pi, it's correct. So I can put it like this, it's pi. Then, where else was it 0? At 2 pi? Okay, so 2 pi, no problem. There's going to be something right here. Then where else was it 0? It's negative pi, so we come to negative pi. It was 0 again here, like this. Then negative 2 pi, that's what it also means. It's going to be 0. So now, how do I then plot? Okay, so since we are, what you do is you then come here and say, okay, if it was at minus 1 like here, it's going to be minus 1 again. But now, if this thing was facing up, now you make it face down. And instead of going to 0, it will be going to infinity. So that's what happens. If this thing is, you see this bar is like this, right? So we just come again to minus 1 here at this point, but we make it do this. So it's going to minus 1, then go back to infinity. Okay, and it's going to be cut, okay, because it can't keep going because of the asymptote. Then we come here, you can see this, it's at 1, so you go to 1, you go to 1 at the center, okay, but look, this bar is facing down, you sweep it so it faces up, so it just make it go to an asymptote like this, then it curves at 1 and goes back up like that. Can you see it? And then it goes back up like this. Then you look at the same thing. It's at -1. You go to -1 again here. Then you make it, since it's bending like this, you make it bend facing down like that. So it's going to be like this, like that, and then go back down like that. You see? And these are your dashed lines, and we keep going. Okay? And then now here, we have ended at 2 pi. Now let's say here they wanted us to end at 3 pi. Look at it like this. You have a curve which is like this going to 1. So yes, you're still going to go to the position. When we were at 3 pi over 2, what position am I at? At 1. That should still be the value. But look now, this thing is curving. Sorry. It's so easy. This thing is curving going down like this, right? Like this. Now you make it curve going up from that one. So here, we still go to that one value, but we now curve going up. And this will be our asymptote, which means we never touch it. Okay, we just come close to it. And this is how we sketch this. Look at how easy it is. We're going to the next video and we will do the same for cos and for sec, okay? Cos and sec, remember they are 1 over cos is sec, okay? Don't forget that. So we should be able to do it. Then we can be able to answer this question in no time. And let's go and do it in the next video. Goodbye for now.